Hello, everyone. Good morning, afternoon, evening. Dear authors and invited guests, welcome to Technical Session 10B. Myself, Ashutosh Goel, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 10th International Conference on ICT for Sustainable Development, ICT4SD 2025, Goa, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event is being held today in Goa, India, and the virtual event is being held through Zoom from 17 to 19 July 2025. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations, and each presenter will be given 10 minutes for the presentation and 2 minutes for question and answers. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chair for this session, Dr. Vijay Mane. Dr. Vijay Mane is the Dean of Analytics and Technical Activity, Associate Professor at Vishwakarma Institute of Technology, Pune, India. With 24 years of teaching and 2 years of industry experience, he brings deep expertise in biomedical engineering, IoT, and image processing. His research contributions include over 60 published papers and 17 patents, reflecting his commitment to innovation and academic excellence. I would now like to invite Dr. Vijay Mane to share a few words of encouragement with our attendees as we begin this session.
Yes, thank you, Ashutosh, and good morning, all. I hope there are some foreign authors also. So, good morning, good evening, good afternoon, everyone. So, this is a great opportunity to all the presenters to share their research that they have done and get some insightful, some feedback from the you can say attendees and from the session chair. So, I congratulate first of all to all the presenters for being selection for the as an paper of for your paper presentation. We look forward to go through your presentations and research work done. Thank you. Thank you, everyone.
Thank you, sir. Now, without further ado, let's start with the first presenter of the day. I would like to call upon Ma'am Deepti Maheshwari to present a paper titled A Comprehensive Review and Future Direction on Hybrid Detection Models for Phishing Websites. Do we have you here with us, ma'am? Do we have anyone else? Yes, ma'am, you're audible.
Yes, sir.
You may start presenting your screen now.
Yes, sir. Sir, I am audible?
Yes, ma'am.
Okay, sir. So can I start?
Yes, ma'am.
Yeah, please go ahead.
Okay. Good morning, sir. And good morning, all of you. Myself, Dipti Maheshwari. A research scholar from Datta Meghe Institute of Higher Education and Research, Savangi Meghe, Wardha. Good morning, all dear dignitaries. My guide, Dr. Salif Gyani, sir, and fellow researchers. I am Dipti Maheshwari, a research scholar from Datta Meghe Institute of Higher Education and Research, Savangi Meghe, Wardha. The title of my presentation is A Comprehensive Review and Future Direction on Hybrid Detection Model for Phishing Website. Let us begin with brief introduction. Firstly, we have seen the content of my presentation is introduction, literature review, research gap, need of study, objective of research, conclusion, and references. Let us begin with brief introduction. Phishing detection system today often combine multiple techniques to improve their effectiveness. These include heuristic-based detection, which relies on predefined rule, machine learning algorithm that learn from data, and anomaly detection technique that identify unusual behavior. Research has shown that combining these methods into a hybrid system lead to much better performance than using any single method alone. This is because each technique bring its own strength, and together they offer a more accurate and reliable way to detect phishing attacks. Next is literature review. Several studies have explored different ways to detect phishing. Kabaji and Kumar in 2018 used rule-based method with random forest. They got good accuracy, but their data was limited. Uh, same Rao, Pace and Gupta in 2019 used machine learning like SVM and random forest, reaching high accuracy, but their model did not work well on new or unseen data. Uh, Next, Baba Goli and Rao in 2019 use hybrid model by combining heuristic and machine learning. These were flexible but struggled with shortened URL. And Ding in 2019 use both content and visual analysis, which improve accuracy and reduce false alarm. Uh, Benavid and Kettle in 2020 use learning which work well on complex data but need lots of label data and is strong computing power. Uh, Same Korkmaz in 2020 use anomaly detection to spot unusual phishing activity. This approach is helpful for detecting stealthy or new type of attack that rule-based system might miss. Next is research gap. Despite extensive effort in phishing detection using rule-based system, machine learning, anomaly detection, deep learning, and hybrid approaches, several significant gaps persist in the current body of research. Um, Model often fail to perform well across different data sets. In poor real-time adaptability, many systems struggle to detect evolving phishing tactics instantly. In high dependence on labeled data, most approaches need large annotated data set, often unavailable. Um, Complex models are accurate but hard to understand. In overfitting issue, many models perform well to training data, but poorly or new unseen sample. Also, there have been significant uh, process in phishing detection. Major gap current model often lack generalizability and struggle to adapt in real time. They heavily rely on large labeled datasets, which limit scalability. There's also trade-off between accuracy and model interpretability. Lastly, overfitting lead to poor performance when dealing with unseen data. Uh, Future conclusion of research gap. In future research should focus on developing lightweight, accurate hybrid system that work in real time, detect anomalies, and adapt to evolving cyber threats. Next is need of study. Uh, Hacker keep changing their trick, so old detection method don't work well anymore. Uh, we have many technique, but they work better when combining in a smart hybrid way. Many systems are either too slow or not accurate enough to stop phishing as it happened. Uh, Most systems need a lot of pre-labeled data to work, which is not always available to up to date. Some models are accurate but hard to understand. Others are simple but not powerful. We need a balance. Current system often make mistake flagging safe thing or missing real threats. We need better precisions. Uh, Phishing detection should run smoothly even on mobile phone or low power devices. Uh, Next is objective of research. To improve detection accuracy and precision, um, um, we have enhanced the overall performance of phishing detection system by reducing false positive and false negative through multi-layer detection approaches. uh, to compare performance across methods, analyze and evaluate individual and combined performance of rule-based machine learning, deep learning, and anomaly detection model in terms of accuracy, interpretability, and adaptability. To enhance model interpretability and transparency, integrated explainable component in the hybrid model to make decision making process understandable to end user and system administrator. To address data set limitation and generalization, explore method for improved model generalization and performance using limited or imbalanced dataset, including synthetic dataset, data generation, or transfer learning. To ensure real-time and scalable detection, create a detection system capable of operating in real-time environment with minimal latency and computational cost suitable for web and mobile platforms. Next is research methodology. In research methodology, rule-based and heuristic approach. This system rely on predefined rule, such as checking for suspicious URL, certain keywords, or fake sender address. They are simple and fast, but not flexible. But this approach cannot detect new or sophisticated phishing tactics that don't match the rule. If we take an example, like an email content the word urgent and the uh, mismatched sender domain, it may be flagged. Next is supervised machine learning. Uh, uh, the model and train on label data. Example of phishing and legitimate emails. They learn pattern and make prediction on new data. Um, but this require a lot of label data and may not generalize well. In deep learning approach, like CNN, RNN, and Transformer can automatically extract complex feature from email content, URL, or web pages. But the limitation of deep learning is high computational cost and low interpretability. In anomaly detection technique, this method look this method look for uh, uh, this method look for behavior that they divide from the norms. They are useful for detecting unknown or zero attacks. Benefit of anomaly detection is it does not need label data for every phishing type, and but the limitation of anomaly detection is high false positive. Not all anomalies are threats. Next is integration on hybrid model. Uh, Hybrid model combine two or more approaches, like rule-based with machine learning or machine learning with deep learning, to improve detection accuracy or robustness. Benefit of integration in hybrid model, it combine strength of multiple method, but this technique is more complex to design and maintain. Next is conclusion. Uh, uh, Now I conclude my topic. Traditional methods are no longer sufficient to tackle advanced phishing threats. Hybrid model offer better accuracy and adaptability by integrating rule-based logic, machine learning, anomaly detection, and deep learning. But challenges is always remain, uh, like integration complexity, data dependency, and lack of explainability. Demand continue research and innovation. Thank you.
Thank you for your presentation,
Thank you so
ma'am.
much, sir.
Are there any questions?
Yes, Dipti, you mentioned
Yes.
several methods for phishing detection. So, are there any standard data sets available, or have you identified any data set to be utilized in future? You understand my question?
Sir, please, sir, repeat.
Yeah, I was asking, is there any standard database you know or you have identified you will utilize in your research? Any standard database data set? Ashutosh, I am audible?
Yes, sir, you're audible.
Yeah, Dipti, hello.
Yes, sir. Yes, sir.
I was asking which data set you are going to use for the research purpose, for the implementation purpose.
Sir, Sir, like fishing tank. It's a community-based data set.
Okay.
Uh,
Have you implemented any of this algorithm?
no such,
It just started.
sir, not.
Okay. Okay, no issues. Thank you. Thank you, Dipti. All the best.
Thank you so much, sir.
We can proceed with presentation.
Yes. Now moving on to our next presenter. I would like to call upon Ma'am Rimple Solanki to present her paper on the title An External Validation Framework for Machine Learning Based Early Detection and Prediction for Surgical Site Infections. Do we have you here with us, ma'am? Do we have anyone else from the team with us? Since there's no response, we'll be moving forward with the next presenter. Next, I would like to call upon Ma'am G. J. Shetty to present her paper on the title APTSUM, AI-powered timestamp-based summarization. Do we have you here with us, ma'am? Do we have anyone else from the team with us? Since there's no response, we'll be moving forward with the next presenter. Next, I would like to call upon Ma'am Ankita Mehta to present a paper on the title Bipolar Disorder Detection using CNN and LSTM, a comparative study of Twitter and questionnaire datasets. Do we have you here with us, ma'am? Do we have anyone else from the team with us? Since there's no response, we'll be moving forward with the next presenter. Next, I would like to call upon Ma'am Sarika to present a paper on the title Brain Tumor Recognition and Classification Based on MRI Images Using Deep Learning. Do we have you here with us, ma'am?
Good morning, sir. Thank you, sir, for giving me a chance to present here over here. Shall I share my screen?
Yes, ma'am.
Is it visible to you?
Yes, ma'am.
Okay. Shall I start my presentation?
Yes, ma'am.
Okay. Thank you so much, sir. Good morning, sir. Good morning, everyone. Here I am presenting my research topic, that is brain tumor detection, brain tumor recognition, and classification using MRI and deep learning. Under the guidance of my guide, that is Dr. Deepa Deshpande, I am a PhD research scholar from Jawaharlal Nehru Engineering College, MGM University, Sambhajinagar.
All presenters are requested to start their videos also during presentation, please.
Okay. Yes, sir. My problem statement is to recognize brain tumor from MRI images, as it is causing more significant mortality due to delayed diagnosis, because brain tumor is predicting several cases as prone to the died only. Manual MRI diagnosis, it is a time consuming and error prone. So there is a need for fast and accurate automated detection of brain tumors from MRI images. Existing models are computationally heavy and less accurate as per the result I got, and as per the literature I have reviewed. Okay, the motivation for my research is enable early detection and accurate classification techniques or the algorithm using deep learning, which will improve the diagnosis method at earlier stage, and it will survive the patients of brain tumors. Objective is to build a lightweight CNN model using MobileNet V2, minimize computational overheads like computational time and computational cost, also achieve high accuracy and the robustness of my model. I have used the data set which is downloaded from the kaggle.com Kaggle website and some online resources also. I prepared my data set with the 4 directories having different types of brain tumors, that is glioma, meningioma, pituitary, and normal tumors, that is no tumors. I have label data set with total images 3,264, in which 926 are of glioma types, 937 are meningioma, 500 normal images, normal tumor images, and 901 are of pituitary tumors. I have pre-processed my data set using median filter, Gaussian filters. I have normalized that images, removed noise from that images, and I have resized that image in the given dimension, that is 224 by 224 by 3 pixels to fit input size for my model. That is, I am using here pre-trained MobileNet V2 model to detect the type of tumors. I have augmented my data set as I am having less images. So I have augmented that images using different augmentation techniques, that is rotation, flipping, zooming, and all. I have augmented that images to improve my model performance, robustness, and generalization of my model. And I have splitted this data into 80-20 pattern of splitting data set into the training data set and validation data set was performed using a random seed to ensure reproducibility. Okay, here is the model architecture. I have used MobileNet V2 pre-trained model with additional dense layer with 512 value units with 4 neurons, as I am classifying my image in 4 different types of image, like 4 different types of brain tumor. So here I am using dense layer with 4 neurons, as the probability of my image will be the of any of the 4 classes. I have made customization in MobileNet V2 model, that is, we have replaced my model classifier, that is highly top level layers, with a custom head to match a number of classes in the data set. The custom head includes fully connected layers with batch normalization to stabilize and accelerate training, with dropout layers to reduce overfitting, and non-linear activation function using ReLU function for feature transformation. I have hypertuned my I have tuned the hyperparameters in such way that to get higher accuracy, I set different values for the parameters like batch size, dropout, input size, dropout rate, batch size, and epochs and learning rates. For the given combination of parameters, I get more accuracy for the for this combination. I have in training configuration, I have used loss entropy loss, cross entropy loss function with smoothing 0.1 parameter I have used Adam optimizer for used for efficient gradient based optimization. I reduced the learning rate 0.001 was selected as the learning rate finder plots were used to verify this range. I have used weighted decay to penalize large weight and early stopping methods to trace out the actual proper values and proper accuracies based on the previous performance during training. I evaluated my model performance using various metrics like accuracy, precision, recall, F1 square, and all. Here I visualize the confusion matrix for model performance and also calculated AUC score for the multi-class classification. That is, AUC is nothing but the 1 over the rest. 1 over the rest means if I am classifying one class over the 4 class, that means it will show the probability of glioma class to detecting glioma class by the model over the remaining all 4. It will give the score, and I have plotted the various graphs for these key metrics, that is training and validation accuracy graph, training and validation recall graph, training and validation precision graph, and ROC curve for various classes like 0.98 AUC I got for the no tumor, 0.9094 got for the pituitary tumor, 0.95 it is got for the meningioma tumor, and 0.84 for the glioma tumor. These are the ROC curves value for various classes of my data set, which I have used to train model and test the model.
This is a gentle reminder that 9 minutes have been completed.
Okay, sir. Here, the result and comparison, I got the accuracy like 98.61. I got AUC for my model. It is 99.70. I got precision and recall for this model. It is 99%, and which outperforms previous models in literature what I have studied, and that is Muslim and Etel. It is also these 4 research papers. I came across these 4 research papers which are using same data set with different methodology, but having accuracy less than my proposed model. Here I have tabulated over here, and if I say about the sustainability angle of my model, it is a lightweight model, deployable in low resource setting, help remote diagnostics where radiologists are unavailable, or it will be the helpful for the doctors to detect the tumor, useful in health and telemedicine applications. Here the conclusion and future work for my model. It is efficient, high performing CNN based brain tumor classifier, achieves state of the art accuracy with minimal computational overhead. And the future work for me, it is extend to 3D tumor segmentation, handle rare tumor types, and deploy with the embedded edge devices. These are the references I enlisted over here. Thank you, sir.
Thank you for your presentation, ma'am. Are there any questions?
Yes, madam. Have you used any data cleaning technologies?
Yes, sir.
You utilize some data set, but have you used any data cleaning or data pre-processing methods in your implementation?
Yes, sir. I have pre-processed my images, my input data set using noise removal and normalization, that is median filters, Gaussian filters I have used. I have implemented all this model using Python programming, and I have used inbuilt functions to pre-process. I have retain my own pre-processing functions also.
Okay, so you
Algorithm.
got that accuracy for a particular database or for all the database?
For all the means my Kaggle. Sir, will you please repeat this question?
You said that you use different data sets, right?
Yes.
So is this accuracy for all the database or and how it is cumulated or
Sir,
average?
actually my database is downloaded from the Kaggle website, which is having different types of image like glioma, meningioma, no tumor, and pituitary tumors. These 4 types of classes included in my dataset, and I have trained the model to classify that images.
Okay, thank you, madam.
Okay, sir. Thank you so much.
Thank you for your presentation, ma'am. Now moving on to our next presenter, I would like to call upon Sir Sarthak to present his paper on the title Brick Manufacturing Using Embedded System. Do we have you here with us, sir? Do we have anyone else from the team with us? Since there's no response, we will move forward to the next presenter. Next, I would like to call upon Sir Rahul to present his paper on the title Diabetes Disease Using Deep Learning Classification in ANN. Do we have you here with us, sir?
Yes, good morning, sir.
Good morning, sir. You may start presenting your screen.
Yes, sir, just a moment. Just a moment.
Sorry, sir.
Is it visible now, sir?
Yes, sir. Your screen is visible.
Okay, sir. Okay. Good morning, everyone. My name is Dr. Rahul Waghela. Currently, I'm working as a director in one of the prominent university in Ahmedabad. My title is basically diabetes disease diagnosis using the deep learning classification in ANN. And these are my co-authors like Kamin Madam, Jay Panchal, Anjali Madam, Genuine Sir, and Nilay Sir. So those are basically working in a Charusep University. Let's move to the abstract. I kept my presentation very precise because we will be asked to complete in 10 minutes. So I kept it with the way. It would be said that I quickly give the some glimpses of the disease itself, that it would be a chronic disease and normally have basically happened because of the what we say the disorder of the sugar digestion. There would be 2 types. Type 1, which is called to be an autoimmune, which is basically been happened because of the deficiency of the insulin. The second was called to be in a type 2, which basically resists to produce insulin or incapacity of the pancreas to produce the insulin. So this basically very two kind of like types of the disease itself. And definitely these are the quick symptoms that it basically create a longer uh, troubles for the everyone, and it would be safe to be for the country like India would be a booming right now. And this basically have the this kind of issues, and long-term issues are very high, like weight loss, fatigue, visible problems are there. Currently, it has been a huge talk of town, frequent urination, excessive thirst. So what exactly the purpose is to have that we could able to recognize or detect early stages, so that could help everyone to have the like precaution, and they could able to avoid it, they could able to do it in a better situation. So this is basically the aim of this particular. So this is what exactly the motivation is there, that most of the time it would be a more error or it would be detected very later stages. So it will create trouble for the people to monitor, as well as treatment will be very hard. So we want to use the ML that we could able to give the diagnosis early, so the treatment could be taken earlier. And we could have used here the data which has been available to us through the again online source data, which we have used around like 768 entries, which basically not that much high, but which help us to understand the primary level disease diagnosis effect. Techniques what we basically combined over here, that all together we do have a supervised and the combination of both That is called to be a semi-supervised. So we basically wanted to do the prediction. So we have tried to use the continuous data over here. So that is what basically reflected here. Sorry. These are the things which we wanted to do. Basically, we want to do the diagnosis that will help reduce the high risk, basically to the person, management, monitor, and we could able to adjust. So that are the purpose. We could able to also do the treatment that has been a personalization, which if we know the things will in a better way, and we could definitely avoid the complications and a longer duration. And we use the ANN and like this data basically we could able to compare, because right now we have done only activation function only because we have gone with the AN and all. But later on, we could able to start with the SVM as well. And we have processed some of the images. And currently, we are going with the data only. So what we do basically as a part of our work, we have clean process data, spread data into the training and testing scale data. So we based on that, we have done the fine tuning, and finally we have done the results. So we try to achieve the accuracy in that. And these are the results, what is basically being shown out data. And these are the nothing but the different, what we say, the reports, what you could see here. And most of the parameter, what is basically used in the, like searching of the rate, that we normally wanted to check that normally it is recognized that the ladies which are basically in the stage of pregnancy would be having the, again, sugar chances. What is the glucose parameter, the blood pressure, the skin thickness, insulin, BMI, okay, and some kind of pedigree functions, if that would be having some kind of heredity. So that kind of parameters are there. Again, the age, and finally, what is the outcomes? We have used basically that how it could be by keeping this particular parameter, the person is basically having the diabetic chances, and that's nothing but not having the chances. So we have tried to utilize that. And these are the steps what we have followed. Basically, we have basically removed the data which is not relevant to that disease. We have actually done the fine tuning of 768 parameters at last. And of course, we have used the binning method in terms of a mean and maximum values to be replaced with that values which is not been available, because we require to remove that blanks and not available data within the same. We divided data into two groups, which is more of 80 and 20%. 80% mostly used for the training and 20% is for the test purposes. And finally, we have done the dependent variable using the standard scalar. So finally, we imported the libraries for Keras, Tens, and TensorFlow. We try to apply on that. And finally, with the hidden layer and different activation function, because we have used the 3 activation function, value, sigmoid, and 10H, and we are able to get the different good results based on that. So we have done the comparison at last as well. And finally, we have able to do the prediction of that person is having diabetes with a good accuracy. So this is basically, this particular reason is also used in the eye disease that is called to be a fundus. So that is one of the, again, parameters that is normally being used in a diabetic person when they are basically having some affection into the eye due to the diabetic. So it is called to be a fundus. So we have the fundus image we could able to process. So currently what we can see here, we have a 4-layer ANN which we applied with the sigmoid. We could able to achieve around 76% of accuracy, which is something good because the data is not that much high. So still we may have a lacking in that later on, but it is still at a good. And we have compared with the ReLU. So that basically giving the 100 epochs, having the accuracy will improve little more. Not that much frequent, but like we could able to recognize immediately, but it would be having the good. Then we have used the sigmoid that basically also having the better performance, and the loss of, like, it would be reduced over the loss of epoch, because if we reduce the epochs, it will basically having the drastic reduction in that. So this all basically been the results what we basically compare. Finally, we have went with the 10H activation function that is again moderately active, helping to do the thing. But again, 100 epochs are required for the evolution. That would be the work for what basically been done as a part of my research work, what is basically been present as a part of this work. And of course that we could able to do the diagnosis, prediction, and treatment for the diabetes. And of course the data is required to be authenticated, and of course the privacy must be maintained. So that is all from my that particular presentation over here. Any questions to ask for that?
Yeah, Dr. Rahul, I couldn't see any result or comparison in the presentation?
Sir, I put it into the text only that 76% result was basically shown out there. That is the only, sir, screenshot which I kept over here because I thought it would be a very precise. I have went with the only data what has been there.
Okay, so have you used any cross-validation methods?
So that is only that what I divided randomly 80% and 20%. Not other than that any.
Okay. Otherwise, because what happens because of this 80 and 20%, you will get some biased results. It is always better
Yes,
to
yes.
use some 5-fold or 10-fold cross-validation methods. So you
I
can.
may go with that, sir. Definitely, I will try to improve the results with the tenfold cross-validation.
And there are other standard databases available also, like Stare, Misidor, DirectDB. You can utilize them also because many papers are use that database to provide their accuracy so that you can easily compare your results with the published
Okay.
results as well. Is it? Yeah.
Yes, sir. I think I have started with the fairly prime work with this particular
Okay.
area. So definitely, I will go ahead with that and will look for the different kind of data set which is been available, which help me to get this particular insight better and better.
Okay. Thank you, sir. Thank you.
Thank you. Thank you, sir. Thank you for the inputs. Any other wanted to ask any question?
No questions. Thank you.
Thank you. Thank you, sir. Thank you.
Thank you, sir, for your presentation. Now, moving on to the next presenter, I would like to call upon Ma'am Dipali Wankhede to present a paper on the title Recent Advances in Deep Learning for Oral Cancer Identification and Classification. Do we have it here with us, ma'am?
Yes, sir.
Okay,
Just a
ma'am. You may
minute.
start presenting the screen.
Let me introduce myself. I am Dipali Wankhede, research scholar from Datta Meghe Institute of Higher Education and Research, Savangi, Varda. Today I am presenting my research paper that is Recent Advances in Deep Learning for Oral Cancer Identification and Classification under the guidance of my PhD supervisor, Dr. Shailesh Gahani, sir, and co-supervisor, Dr. Mrunal Mishra, ma'am. Here are the contents of my presentation, which includes abstract, introduction, fundamentals of deep learning in medical image analysis, deep learning techniques for oral cancer identification, classification of oral cancer using deep learning, challenges in deep learning based on oral cancer detection, conclusion, and references. Here is the abstract of my research paper. Basically, this paper gives the review on how deep learning transforming the early detection of oral cancer, because oral cancer often gets diagnosed at very late stage and making it one of the most fatal disease in society. So early detection is a key for improving survival rates. Second, recent advancements in deep learning have revolutionized medical imaging. So techniques like CNNs, convolution neural networks, recurrent neural networks, and deep reinforcement learning have shown excellent accuracy in identifying cancerous tissues earlier than ever before. And we also explored some multimodal learning where data from different sources like radiological scans and histopathological slides are combined to improve the precision in tumor segmentation and classification. Another highlight is that the models are now becoming more transparent, so we can interpret why the model is giving some decision, so which is critical in high-stake fields like healthcare. Since collecting large volumes of clinical data is difficult, transfer learning and self-supervised learning are used. So these approaches let the models learn from limited or unlabeled data efficiently. Here is the introduction which gives the information about the oral cancer. Oral cancer is a serious health issue, especially because it's often diagnosed too late. So if you see the statisticals data in year 2020 alone, there were around 3,77,000 new cases and 1,77,000 deaths worldwide. So the chances of survival for 5 years after diagnosis are just 50% on an average. But if we see towards the rural areas, this drops drastically to low as 10 to 15% only. The main causes of oral cancer include tobacco, alcohol use, and betel cord use, genetic predisposition, economic inequities, like in rural areas people might not get proper medical treatment for a disease like cancer because they can't afford it or there are no hospitals nearby. And even poor oral hygiene is one of the reason for oral cancer, especially in South and Southeast Asia, where 90% of cases are specific type of oral cancer, that is called OSCC, which stands for oral squamous cell carcinoma, which is the most common type of oral cancer. It is the cancer that starts in the flat cells lining inside the mouth, like the tongue, cheeks, gums, or floor of the mouth, and it can spread quickly if not detected at early stage. So in India, 60% of the oral cancer cases are detected at a very late stage, and around 30% of patients delay treatment for more than 3 months. So early detection is very important. Plus, public awareness, screening, and easy access to healthcare are key for saving the lives. Artificial intelligence, especially deep learning models like CNNs, can analyze medical images faster and more accurately. So this leads to earlier and more reliable cancer detection. Despite of all these benefits, there are some challenges also, like limited data sets available for training the artificial intelligence systems, lack of clarity in how AI models make the decisions, and which affects the trust in clinical use of these architectures. Fundamentals of deep learning in medical image analysis. So here this table summarizes the core components and approaches for of deep learning that are widely used in medical image analysis. So out of these 8 research papers, if we highlight on first data, here convolution neural networks like AlexNet, GoogleNet, and RaceNet are fundamental in general medical image analysis, working across multiple body parts, and they help detect various diseases with high accuracy. So this data highlights how convolution neural networks have become the backbone of modern medical image analysis. Overall, the table provides a quick overview of deep learning foundations, models, learning strategies, and use cases, so that drive innovation in medical image analysis, especially for early detection and treatment planning. This is the second table in which it is more focused on deep learning techniques for oral cancer identification. So this table summarizes various deep learning approaches used specially for detecting and diagnosing oral cancer using medical images like histopathological data, intraoral photos, or radiology scans. So first row, if we highlight the use of smartphone based imaging combined with deep learning models like HRNet and RaceNet to detect oral cancer. And HRNet showed superior performance, improving the F1 score by 8%. However, image quality differences from smartphones pose the challenges to accuracy and generalization. Next is classification of oral cancer using deep learning. So, deep learning models can classify oral tissues as normal or cancerous. So, helps in early diagnosis and identifying cancer subtypes for personalized therapy. Again, improved diagnosis with CNNs and UNIT type of architecture. CNN extract features from medical images for accurate classification, and architecture like UNIT performs image segmentation to define the actual tumor boundaries, so which help in surgical or treatment planning for the medicines. Enhanced platform performance with pre-trained models. So as one of the challenges is the lack of data. Concept like transfer learning uses the pre-trained networks like RaceNet, VGG to improve the results with limited data. Again, the techniques like data augmentation, which is used to boost the model generalization by creating variety of training samples. Here I majorly focuses on the challenges in deep learning based oral cancer detection. Annotating medical image requires expertise, like labeling the cancer regions on medical images needs domain expert like pathologist or radiologist. Then limited and imbalanced data set, like oral cancer data sets are often small and certain cancer types. So detect early stage or rare cases. So they may become biased towards the common classes, missing less frequent but critical condition. Uh, Then lack of diverse and multi-institutional dataset issues. So many datasets come from a single hospital or region, so lacking the variability. Then model bias, if the training data does not reflect the broader population, that is if it includes only the images of light-skinned individuals or one age group, so the model may become the bias. Overfitting, next challenge is overfitting makes model less effective when applied to new patient population or clinical condition. So it requires the strategies like cross-validation, regularization, and augmentation to improve the generalization. Here is the conclusion of my research paper, which states that advanced CNNs like DenseNet and RaceNet improves the early and accurate oral cancer detection by classifying images effectively. Self-supervised learning and multimodal AI combining image plus clinical data help to distinguish between benign and malignant lesions. Key challenges include small dataset and poor generalization, which call for standardized data protocols and multi-center collaboration. And future research should focus on explainable AI, reducing bias and enabling real-time diagnostics tools. So collaboration between AI researchers, clinicians, and policymakers is essential to ensure the fair and effective use of AI in oral cancer detection. So these are the references. I have referred total 23 research papers to write this article. Here I have mentioned some of them. Thank you very much for your patiently listening.
Thank you for
Any
presentation,
questions?
ma'am. Are there any questions?
No questions from my side. Thank you, Deepan.
Okay, thank you very much, sir.
Thank you, ma'am. Moving on to our next presenter, I would like to call upon Ma'am Wrinkle Solanki to present a paper on the title An External Validation Framework for Machine Learning-Based Early Detection and Prediction of Surgical Site Infections. Do we have you here with us, ma'am?
Good morning, everybody.
Yes, ma'am. You may present your screen.
Yes, am I audible?
Yes, ma'am.
Thank you so much. Good morning, everybody. My name is Wrinkle Solanki. I am from Tagore College of Engineering and Technology, and my guide is Dr. Shailesh Ghane, sir. And I'm doing this research under his guidance, doing it from Datta Meghe Institute of Higher Education Research from Swangai, Wardha. The title of my paper is An External Validation Framework for Machine Learning Based on Early Detection and Prediction of Surgical Site Infections. So these are the contents of my research, which includes the introduction, the literature review, the research gap, the study, the objective of the research, the conclusion, and the references. So, as we all know that during surgeries, there are a lot of complications uh, which happens while the surgery is going on, and that is a major cause of uh, delay in the entire process of medical. So this particular my research is going to help us that how we can early detect any kind of infections among the patients, which can lead to betterment in the patient at the later stage. So surgical site infection is affecting 2 to 5% of the patient surgeries, leading to increased morbidity, extended hospital stays, and higher medical cost. Conventional detection relies on clinical assessments, lab tests, which are reactive and prone to delays and inconsistency due to interclinical variability. So there is a lot of inconsistency, there is a delay in the clinical treatment, and that is the reason why we need to make sure that whenever we are going for any kind of surgery, whether all the basic things have been tested well, so that it gives us an early detection and an early prediction, which machine learning is going to help us to early predict the patient's health and what are the further things which we need to do. The subjective judgments and delayed responses in traditional methods hinder timely intervention and affect the treatment of the surgical site infection. Machine learning is going to basically help us to find out the data along with the clinical parameters and surgical information to identify the early infection risk. It is also going to help us to improve the patient outcomes, and definitely the cost of medical is very high, like the entire treatment of the hospital is high. So that is going to help us and reduce the cost. And models trained on specific data sets may not generalize across the institution due to variations in patient profiles, surgical practices, and microbiological environments. This particular study is going to help us to prepare an entire validated framework to test the with the help of the machine learning model, to prepare an algorithm which with the help of different data sets, so that we can early predict and we can early detect. This framework ensures that ML models for surgical detection are accurate, generalizable, and applicable in all kind of clinical settings. This is the literature review of my findings. I have gone through the electronic health records, patient demographics using logical regression, and the output was that we were able to identify the accuracy, the sensitivity, and the specificity, and we were with the help of this particular paper, we were able to reduce the complications and we were able to identify it as well. In the second paper, again, we used lab results, we used surgical data. Okay. In this particular as well, the findings were that we were able to give better clinical decisions, and here it definitely helped for post-operative issues and gave us better data-driven predictions. The next is the retrospective study using ML on EHR data sets to detect the surgical site infection before any kind of symptoms, wounds. Even the diabetic patients has different wounds, and the wounds are, we are unable to find out the cause of that. So in this particular paper, that was the finding, and we were able to, and the remark was that we were able to have use the random forest and deep learning technique in order to detect it. So in this particular research, I was able to identify the lack of external, what is the actual research gap over here is the external validation, real world applicability, inconsistent evaluation frameworks, and delayed clinical support, and underutilization of multimodal data which is available. This is what we have found out while I was going through the different topics, the different researches which are available, and with the help of the guide. So this is a conclusion of the research gap, that we were able to identify the gap, and we were also able to have a validation framework. We have rich data sources. We are able to also identify predictions with the help of surgical site infection scenarios and data available. We were also able to identify evaluation matrix, and we were able to improve the clinical workflow integration, that how we can integrate this particular algorithm or this particular finding into actually surgical site infections, and that we can also enhance, of course, the main concern when it comes to any health or anything, it is always the patient's safety, his security, his the cost, and everything gets involved over here. So why we actually need to study this? There are these traditional methods of finding out, diagnosing, that needs to be, that is the reason why we need to have a study on the surgical site infections which are going through. We also, we need to understand the importance of external validation, and we also need to understand the different potential machine learning algorithms which are useful for surgical site protection. And we also need to definitely identify what are the challenges, what are the opportunities for surgical site infection. This is my external validation, which we have predicted that we need to collect the data. We need to apply feature engineering. We need to apply model development, external validation, model integration, and assessment and iterative improvement. So we need to, this is the validation scenario, which what to say, a table or a flow which we have created, that we need to collect the data, we need to process the data, we need to develop it, we need to validate it, and then we need to integrate it. And we also need to assess it. And definitely, after assessment, there is always a scope of improvement. So we need to improve it as well. Okay. These are the procedures for the surgical site infection, that is data privacy. We need to take the consent. There doesn't need to be any biasness in this. And if there is any liability issues, and of course, data security. These are the consents, whenever we take a consent, these are the things which we follow.
This is a gentle reminder that 9 minutes have been completed.
Okay. The objective of the research was to establish a machine learning framework and to identify the predictive factors of surgical site infection risk. What are the risk factors? Also need to optimize and validate the machine learning models and generalize it through external validation, how we can generalize everything, and how we can integrate this study, which is the external validation, using machine learning framework into healthcare. That is the entire objective of this particular study which I'm trying to do. And of course, there is a continuous improvement in the framework which we need to follow. Okay, the research methodology, the payment history documentation, the data privacy, and the contemplations, storage and medical histories. And this is the conclusion. This is the last, second last slide. We are trying to integrate the health records with machine learning to give us accurate detection. We are trying to also have a structure with the electronic health records, which are definitely important for machine learning. We need to improve the diagnostic accuracy. We need to reduce any kind of delay, and we need an optimization on the patient outcomes. We need security and compliance, and external validation standardization enhances reliability and generalizability of machine learning models. It supports predictive analysis with diverse health settings and promotes proactive data-driven infection prevention, improving surgical care and health cost. So these are the references which I followed, which I went through. Total papers referred was 19. So this is the last slide, and this is the end of the presentation. Thank you very much for listening to this and allowing me to give the presentation.
Thank you for your presentation, ma'am. Are there any questions?
Yeah, I just want to ask, what would be your as an input and the output of this proposed system?
So the input would be if any particular patient is going to undergo a surgery, so there will be a series of steps. For example, if the patient has a wound, so what are the series of steps or the series of basic checks which the patient needs to go through? That will be the input, and the output will be, of course, the results or whatever the reports will be. And is he fit to go under that particular surgery or that particular operation which he has been admitted for? So this is the input, the process, and the output.
Okay, but you mentioned that you are having some surgical site infection. So is it just before the surgical happens or after surgical happens?
So this is mainly before the surgery and during the surgery also. We are going to combine both the things, but mainly it is before the surgery. If the customer is facing any kind of infection, so how are we going to deal with that? That is a generalized algorithm which we are trying to prepare.
Okay. Is there any current algorithm or existing solution available for this?
So there are quite few available, but right now we are under the process of making one. Uh, right now we are in the process of making the new algorithm so that we can generalize this in the future.
Okay. Thank you. Thank you very
Thank you,
much.
sir. Thank you for your questions.
Thank you for your presentation, ma'am. Now moving on to our next presenter. I would like to call upon Ma'am Ankita Mehta to present her paper on the title Survey on Prediction of Bipolar Disorder using CNN and LSTM. Do we have you here with us, ma'am?
Yes, sir. Sir, sorry, I have two presentations. So,
Yes, ma'am, you may start the presentation.
yes. Yes. Good morning, everyone. Myself, Ankita Mehta, and my topic is my guide name is Dr. Shailesh Kahane, and I am pursuing my PhD from Datta Meghe Institute of Higher Education and Research, and my topic is survey on prediction of bipolar disorder using CNN and LSTM. So these are the content which I am going to explain: introduction, literature review, research gap, need of study, objective of research, proposed steps, conclusion, and references. So first of all, I would like to say about bipolar disorder. So what is bipolar disorder? Bipolar disorder is a serious mental health condition. uh, it is a mood disorder. In this disorder there are two phases: mania and depression. In case of mania, patient is in extremely hyper state. Means if he has a 4 hour sleep, but he can be energetic like anything. He can do any work with energy. These symptoms come in mania episodes, and this could be of 7 days, 1 month, and 15 days. So this is a mood disorder. Mania and depression are two phases of this disorder. So it is very crucial condition. In depression phase, patient can do suicide also. So there are different types of matlab, bipolar roles. So I would like to tell about role of technology, advances in technology, especially artificial intelligence. Oh, sorry. Sir, am I audible? My screen is visible, na?
Yes, ma'am, you are audible and your screen is also visible.
Okay. Bipolar disorder involves mood swing for intense elation, that is mania, to deep depression, making its management essential for quality of life. So, what are the role of technology? Advances in technology, right, especially artificial intelligence, and open new possibility for understanding and predicting mental health condition like bipolar disorder. So, with the help of artificial intelligence, it would be easy for psychiatrists also to predict bipolar disorder patient, to predict it as early as possible, and it would be beneficial for patient also. So many researchers have worked on this. Machine learning and deep learning are revolutionizing medicine by analyzing large data set to detect patterns that might otherwise go unnoticed. These technology help researchers identify signs, symptoms, behavior related to bipolar disorder, leading to better understanding of the disorder. So So this is the literature's review which I have gone through. My first paper is I have gone through 22 papers, but I have mentioned here 6 to 7 papers. A diagnostic model based on bioinformatics and machine learning to differentiate bipolar disorder from schizophrenia and major depressive disorder. So these are the three disorder which have a similar kind of symptoms. Sometimes psychiatrists also get confused, so whether the person is having schizophrenia, major depressive disorder, or bipolar disorder. So what are the focus of this study? The primary focus on identify candidate genes and assess their diagnostic value in distinguishing bipolar disorder from schizophrenia and major depressive disorder. ANN network showed that artificial neural network have performed best in this case. So these are the limitation which I will be explaining later. Second is bipolar disorder detection using machine learning. So the focus of this study is to detect bipolar disorder by analyzing clinical and neuroimaging data. So the model used in this is logistic regression, decision tree, random forest, support vector machine, neural network, and deep learning. The study concludes that the machine learning algorithm shows promising. All machine learning algorithm shows promising potential in accurately detecting bipolar disorder. Third is semi-supervised and supervised learning for mental health monitoring. The focus of this study is comparing semi-supervised and supervised machine learning. The conclusion is that the semi-supervised machine learning have performed better. And the fourth one is automated diagnosis of bipolar depression through Welche periodogram and machine learning technique. The study primarily focused on analyzing EEG signal during rest, extracting features using the delta, theta, alpha, beta, and gamma bands. So author has tried to analyze bipolar disorder through EEG reports. EEG reports shows in EEG reports we have this 4 and 5 bands: delta, theta, alpha, beta, and gamma. So on the basis of this, author has tried to analyze the whether the person is having bipolar disorder or not. Here model used SVM, KNN, LDA, RBF. The SOM neural network achieved higher accuracy and sensitivity and specificity rates of diagnosing bipolar disorder uh, have been used, sensitivity and specificity. Fifth is extracting mental health condition from English and Spanish social media. Automatic recognition of mental health condition in English and Spanish Twitter users using traditional and deep learning algorithm. Here author have used Twitter data sets, and XGBoost and CNN models have been used to detect bipolar disorder. And data set is Twitter data set. Findings is XGBoost and CNN neural network perform both best in this study. A review of Sixth is a review of machine learning and deep learning approach on mental health diagnosis. The study focuses on assessing machine learning and deep learning approaches for diagnosing and predicting treatment outcome of various mental health condition. Model, naive Bayes, LSTM, random forest, and support vector machine have been used. So these are the research gap in my literature survey which I have gone through. Limited sample size. Sample size is very limited. So overfitting risk could be there. Lack of ethnic geographic diversity reduces generalizability. No clinical validation or testing on diverse patient population. The data, the research is not reliable till now because there is no clinical validation or testing on diverse patient population. Long-term effectiveness of models not evaluated, and this disorder cannot be predicted in one go. So we have to monitor patient for at least 15 days. So limited use of advanced signal processing technique beyond Welch analysis. Self-reported Twitter data lacks validation by medical experts. Challenges like overfitting because we have limited sample size, small data set, and overlap affect ML and DL reliability in mental health diagnosis. So need of this study is early and accurate diagnosis challenge. A limitation of traditional diagnostic method. As per my knowledge and as per my survey, there is no automated system have built till now for predicting bipolar disorder. Uh, psychiatrist psychiatrist use the survey. Psychiatrist uses survey for predicting bipolar disorder. Need for high performance ML models, multi-model and hybrid approach gap. There is no multi-model and hybrid approach available. Lack of large diverse data set, underutilization of real world digital data, clinical implementation and validation is missing. Objective of the research to evaluate and compare the performance of various machine learning algorithm to develop a deep learning based predictive framework by integrating 2D convolutional neural network for special feature extraction, and then the output will be given to bidirectional LSTM for modeling temporal dependency in EEG spectrogram. We can I have mentioned here EEG spectrogram. We can have a multi-model data set also, different data set like Twitter, EEG, EEG data sets, Twitter survey data sets. We can use many data sets to enhance early detection and clinical decision making in bipolar disorder diagnostic by demonstrating the effectiveness of EEG based deep
This is
learning
a
model. Yes,
this is a
sir.
gentle reminder that 9 minutes have been completed.
Yes, sir. Uh, EEG based deep learning model with the goal of improving patient outcome through timely intervention and personalized treatment. So this is the proposed step. This is my survey paper. So I have gone through many literature reviews, 22 literature reviews I have gone through, and I have proposed CNN and LSTM model. So this is the proposed step: pre-processing, segmentation and labeling, then feature extraction from the data set, and then max pooling will be there. Then that output will be given to LSTM. Then we will classify with the sigmoid activation function whether the person is bipolar or not. Sigmoid activation function may we will the binary output will be there, and then we will optimize the model. So this is the conclusion. CNN BiLST model achieved a higher accuracy of 95% till now in predicting bipolar disorder. So I have decided to work on this only. EEG spectrogram effectively captured spatial and temporal feature. The model support early and accurate diagnostics. Deep learning outperformed traditional ML models like SVM and XGBoost. The approach is clinically useful for real world mental health diagnostics, is scalable and adoptable with larger data set for future use. These are the references, and I have many other references also. I have mentioned few of them here. Thank you so much. Any question?
Thank you, madam. You are
Yes.
using here EEG spectrogram, right?
Yes, sir.
Do you know which device is used for obtaining EEG spectrogram?
Sir, electrodes.
The device. Electrodes.
Sir, I am not aware about the device.
Okay.
Yes, sir.
And is there any, do you know what are the standard data sets available for EEG
Sir,
spectrogram?
I have taken data sets from Kaggle. I have not got any reliable data sets, but for this is the survey paper. For the future studies, I will be sitting with the psychiatrist as I am pursuing PhD, and then I will try to gather data sets from them
Oh.
for
And in the
reliable.
spectrogram, how many waveforms are there? Any idea? Do you know how
No,
many
sir.
waveforms are there?
No,
What are
sir.
the patterns?
Patterns, sir, I'm not. Can you please elaborate it? What waveform? I'm not aware, sir.
Okay,
Uh,
no problem. No
okay,
problem. Thank you,
sir.
madam.
Okay, sir. I have one more paper to
Yeah, you
present.
can go ahead.
Okay, sir.
Yes, ma'am. Let me share the flyer once, then you can start presenting your screen again.
Okay, sir. Okay, so shall I present it now or after some time?
Just a minute, ma'am.
Okay.
Ma'am, Ankita will be presenting one more paper on the title Bipolar Disorder Detection using CNN and LSTM a comparative study of Twitter and questionnaire datasets. You may start with presentation now.
Okay. Sir, my screen is visible?
Yes, ma'am.
Yes, sir. Sir, this is my topic, bipolar disorder detection using CNN and
Actually,
LS.
ma'am, I'm sorry to interrupt you, but it is on the previous paper on the thank you slide.
Huh?
The screen is showing the thank you slide of the previous paper.
Okay, okay. Sir, now it is visible, paper ID 14.
Yes, ma'am.
Mhm. So, my second topic is bipolar disorder detection using CNN and LSTM, a comparative study of Twitter and survey datasets. So, these are the content which I am going to explain. So, again, bipolar disorder is a crucial for overall health disturbance like bipolar disorder impact deeply in our daily life. If a person is suffering from bipolar disorder, he can have a serious problems in his daily life, like, oh, he could be over expensive in many episodes, he could be overly involved in social activities. So these are the symptoms of mania. These are not the only symptoms, these are the symptoms of bipolar mania episodes. In depression, he could be in extremely low mood, means these are mood disorders. So in many episodes, he could be a high energy. He will think like, I'm superior, I'm out of the world. And so these are the mindset a person suffering from bipolar disorder have. And depression phase, he thinks that he's good for nothing, and all these are the some symptoms a bipolar patient have. So these are the categories of bipolar patient. Bipolar 1 disorder includes severe mania and depressive episodes often needing high hospitalization. Bipolar 2 disorder feature milder mania with severe depression and emotional fatigue. Cyclothymic disorder has mild frequent mood shifts beginning in adolescence. Mixed feature shows symptoms of both mania and depression at once. Sleep issues, racing thoughts, helplessness, and rapid cycling involves 4 plus mood episodes per year with frequent switches between highs and lows. This is a mood disorder. So this is the literature survey which I have gone through. Finding mental insecurity utilizing machine learning. So focus of the study is psychological instability detection among working individual. Random forest and KNN have been used. Random forest achieved 87.02% accuracy, and limitation is it is only working on it is only for working individual. So second one is identification of bipolar based on CNN. Use of SNP data to identify bipolar disorder. Convolutional neural network. Reported accuracy 79.2%. Low sample diversity, moderate accuracy. Overfitting risk would be there. Survey on ML and deep learning in mental well-being. Third one, review of ML and DL techniques in mental health diagnosis. Naive bias, LSTM, and random forest have been used. Highlighted effectiveness in detecting various disorders, including bipolar disorder. So, ML for schizophrenia and bipolar prediction has, as I have already explained, schizophrenia and bipolar disorder have similar kind of symptoms. So it is difficult for psychiatrists also to differentiate it. So this paper differentiating between schizophrenia and bipolar disorder. Various ML algorithm have been used to detect this. Random forest was most effective for bipolar disorder detection in this study. So bipolar versus borderline personality disorder, distinguishing in this paper we are distinguishing these two disorders. So ML method have been used to differentiate, and ML classification technique have achieved high accuracy. Automated diagnosis via Welche periodogram and ML. Detection of bipolar depression. EEG data plus Welche periodogram achieved 97.62% accuracy. Focused on EEG data. Result may vary across EEG equipment or patient states. Diagnostics model via bioinformatics and ML. BD versus schizophrenia versus mood depressive disorder classification and bioinformatics plus artificial neural network. So these artificial neural network achieved higher precision in differentiating bipolar disorder from other disorders. So these are the research gap. Only first in the first paper, it has only worked on the working individual. So overfitting risk could be there if we use that model for other people. Small genetic data, so there would be overfitting risk also. So no experiments, only theoretical. Survey paper is only survey is there. No reliable data is available for predicting bipolar disorder. Weak explainability and unclear data. Bipolar disorder versus borderline personality disorder hard to separate. Lacks real data. EEG only, no multimodal check. Data heavy, not generalizable. Need of the study. Bipolar disorder is increasing globally, yet early and accurate detection remains a challenge. Most existing models lack deep learning implementation or real world validation. This study uses CNN model on both structured and unstructured data. So what is the difference between the previous presentation which I have explained and this presentation? Here I have used two data sets. Both I have taken from Kaggle, and in the previous paper was my survey paper only. Here I have implemented this using CNN and LSTM. So I have applied this algorithm on the survey data set and Twitter data set. So survey data set performed better for predicting bipolar disorder. So our goal is to build an effective and deployable system for mental health monitoring. To develop a CNN LSTM model for early. This is the objective of my study, for early and accurate detection of bipolar disorder using machine learning and deep learning technique to compare the performance of the model on two different data sets, a structured survey data set and unstructured Twitter data set. As per my study, psychologists used survey data set as DSM-5, MDQ. These are some surveys which help psychiatrists to predict whether the person is bipolar patient or not. So I have used survey data and unstructured Twitter data also for sentiment analysis, you can say, to analyze the effectiveness and feasibility of using real world data for building deployable mental health monitoring system. So social media data I have taken, and this is not multi-model data. I have used two different data. Sorry, this is wrong. Multi-model data I have not used. I have used two different data sets. For one for Twitter data sets separately I have implemented, and one for Twitter data sets I have implemented. I have applied CNN. First CNN will extract a special feature map will be used, then max pooling will be used, and that output will be given to the LSTM, and LSTM will see the temporal dependency, and then finally it will predict whether the person is bipolar patient or not. So the conclusion, these study developed a CNN LSTM model to predict bipolar disorder using survey and Twitter data. The model performed significantly better on structured survey data, 94.82% accuracy, than on unstructured Twitter data, 60.99% accuracy. This shows that well-structured data set, which is survey data set, predict better. Social media data needs more advanced processing for reliable result, like LLM model we can use for large for Twitter data sets. The study highlights the need for high quality data in mental health prediction task. So these are the references, and thank you so much. Any question?
And no more question, madam. Thank you.
Thank you. Thank you, sir.
Thank you for your presentation, ma'am.
Thank you.
Now moving on to our next presenter, I would like to call upon Ma'am Vijeta V. Shetar to present a paper on the title Voice OTP Authentication and Advanced Speaker Verification System. Do we have you here with us, ma'am?
Actually, how many are remaining now?
Sir, including Ma'am Vijeta, three people are remaining.
3 presenters are there. Okay.
Hello, everyone.
Yes, ma'am.
Is my screen visible?
Yes, ma'am.
Okay, my research goes under, I'm Vijeta Vishettar. I'm a Bachelor of Engineering student at KLE Technological University. So my title is Voice OTP Authentication and Advanced Speaker Verification. So this voice OTP authentication has two-factor authentication, which is authentication and then authorization of the speaker. So it is one such system that provides authentication. Initially, it verifies the speaker's identity, that is whether it matches with the speaker's voice. Then after that, verifies the spoken OTP, speaker recognition, and also digit recognitions is involved in this process, which are both amateur speech technologies that perform well in practical deployments. It also leverages the uniqueness of the individual voice, making it difficult for any unauthorized users to impersonate someone else. It is particularly beneficial for users with disabilities or those having difficulty in typing or using traditional authentication methods. So the one important and crucial application of voice OTP is under the sector of banking, since each user has a unique voice. Nobody can try to take those bank sensitive informations. So there are different types of OTP authentications. They are SMS based, email based, biometric OTP. So each of them have their own strength and weaknesses, and each of them can be used around various applications. Such as SMS based is very easy to use and quickly accessible. Weakness is that if anyone else can access your OTP through your messages, then easily your informations can be leaked out. This can also be used where two-factor authentication is required. Then comes the email-based OTP. It is also easy to implement, but sometimes what happened, the OTP is just for few seconds or few minutes, and if by chance the email goes to the spam or it gets delayed, then it is very difficult to, it is not very quickly accessible. And application are basically password recovery of any social media or any other sites, and to log in also. The third type comes with the biometric OTP. The strength is it combines your own unique biometric and also the OTP security. And the weakness is you need to deploy it on some hardware. It requires some hardware deployment. But the application is where you need advanced security levels, such as banking, as I mentioned. There it is very useful. So here comes the question, why to choose voice OTP instead of others? So the first thing is securing information is very fast and it is also reliable. There are very good security measures by using this. It provides an extra layer of security and also reduces the risk of phishing attacks. So my problem statement is to develop a text-independent speaker verification for a voice-based OTP authentication systems. And the objectives are to verify initially the user's identity using voice recognition. There are several models for them to recognize the speaker. Then to support multiple languages for diverse users accessibility. Since India is a diverse country, we have many languages across the country, people using very different languages, and to provide an additional layer of security through voice-based authentication. So the literature review comes like, so the first paper which was addressed was the MSV challenge, multilingual and cross-device speaker verification constraints subtasks. Here the model used was ResNet SC34V2. So basically this model is very lightweight, having the ResNet architecture with 8 million parameters, and it also has attentive statistics pooling for fixed length embeddings. Then for the scoring, we use cosine similarity. Then comes the MSV Challenge 2022, which is the better version of this NPU-HC speaker verification system for low resource Indian languages. This paper uses model eKappa TDNN. It combines the TDNN. TDNN is nothing but time delay neural network with squeeze excitation. Again, rest to net blocks are used. It also has the ASP. It focuses on speaker verification in low resource Indian language settings. Then the third paper is Popcorn System for Indian Multilingual Speaker Verification. It uses TDNN ResNet SE34V2. This also uses multilingual speaker data, implements TDNN for feature extraction, and ResNet block optimized for multilingual scenarios. Exploring invariant embedding with TDNN features for MSV challenge. The model used here is again TDNN. TDNN layers for temporal feature extraction, then softmax for classification objectives, and for scoring cosine similarity is used. So the next paper is multivariability speaker recognition database in Indian scenario. It uses eKappa TDNN, TDNN. So this paper uses the IITG multivariability database with multivariable factors such as sensor, language, environment, style, etc. eKappa TDNN for multi-scale feature extraction and speaker verification. Then the paper eKappa TDNN is used to learn about the model, how the eKappa TDNN works. So here it enhances TDNN with squeeze excitation, rest-to-net blocks, multi-layer feature aggregation for better embeddings, uses statistics pooling for fixed length output. So the functional block diagram of my methodology goes like this. The model is initially trained using audio sample and speaker labels, extracting embedded vectors via speakernet, TetaNet small, and TetaNet large. Basically, these three models extract the embedded vectors from the input audio samples from the data set, and the data set used here is the IITG multivariability data set, which is a collection of speech data designed for speaker recognition and voice biometrics. So basically this data set uses recordings from 48 speakers, including both male and female, spoken across 8 Indian languages like Assamese, Bengali, Hindi, Kannada, Malayalam, Marathi, Tamil, and Telugu. The dataset features multiple microphone setups capturing speech from different angles and distances, making it useful for the speaker recognition models in different environments. It's multilingual and varied recording condition make it an amazing resource for developing robust real-world speaker recognition systems. So during testing also, a new audio sample is processed to extract the embedded vectors, which are then compared to the training data. The model identifies the speaker based on the closest matching vectors.
This is a gentle reminder that 9 minutes have been completed.
Okay. So after all the literature survey and everything, the best suited solution goes like this. So it is kind of a comparison between different NVIDIA models. Those are the SpeakerNet, TitaNet Small, TitaNet Large, for the speaker verification. So initially the input audio is taken, features are extracted from the audio data. After that, speaker model, that extracted features are then provided to the models like SpeakerNet, TitaNet Small, TitaNet Large. Same happens with the testing phase also. After getting those embedding vectors, we are matching those vectors and providing whether the speaker recognized is correct or not. So implementation details goes like this. So model descriptions, SpeakerNet is nothing but it extracts speaker specific features using deep neural network, focuses on voice characteristics while filtering out the noise. So in pre-processing of the SpeakerNet, the model then and there filters out the noise. Then comes to TitaNet Large. It captures fine voice details with high accuracy, making it
Ma'am, you
ideal
have
for.
exceeded, ma'am, you have exceeded the 10-minute time limit. Kindly conclude the presentation.
Okay, sure. So, coming to the comparison of the experiment results, so the experimental results were taken by using the confusion matrix. So, for each model, the accuracy performed for SpeakerNet was 85%, then TitaNet Small for 75%, and TitaNet Large was 80%, which then gives us the performance insight like the SpeakerNet is good at rejecting non-matching speakers but struggles with recognizing the valid matches. TitaNet Small fails to identify any valid matches, needs significant improvement in embedding quality. TitaNet Large.
Vijayda, thank you. We understand. Thank you very much.
Okay.
Thank you for your presentation, ma'am. Are there any questions?
Ashutosh, no questions. Go to next presentation.
Okay, sir. Moving forward with the next presenter. Now I'd like to call upon Ma'am Jia J. Shetty to present her paper on the title Apt Sum, AI-powered timestamp-based summarization. Do we have you here with us, ma'am?
Yes, sir.
Yes, ma'am. You may start presenting your screen.
Yes. So, good morning, everyone. Today, myself, Jay Satvi, with Anish Pranav, here to present on the topic AI-powered timestamp-based summarization. So, in the digital age, we are constantly bombarded with information, especially through news articles, research blogs, and reports. Our aim was to address this information overloading by building a AI-powered system that can summarize massive volumes of data while preserving the temporal relevance with the timestamp. So this system doesn't just summarize; it does generate daily, weekly, or monthly summaries chronologically. We use this transformer-based NLP model and achieve a strong result with the Rogue score, which indicates high quality and human readable summaries. And this is also scalable and configurable. Unlike tradition, next is for the introduction. Unlike traditional summaries, our system respects time-sensitive context. For example, it is an event which unfolds several days or weeks, and our summary will capture that evolution. Instead of giving you a disjointed or partial screen a snapshot, it shows the summaries based on the time. This is especially valuable in areas where journalism, research analysis, or crisis reporting comes into the play. So we use modular serverless workers, and event-driven pipelines. Next, for the literature survey, there are five papers on focus in which the core theme is summarization. They explore techniques like RNN, transformers, T5, and BERT. Their goal aligns with helping users understanding the evolution of events chronologically. The main gaps of this was it doesn't handle ambiguous or implicit time expressions well, and the false or noisy sparse data set was the main limitation here. For the limitations, um, the temporal ambiguity, which is in many systems, they break the sequence of events. The second one is different writing styles affect the consistency of the summary and the timestamp. Next is in fast evolving topics, the different writing style affect the poor quality and the interpretability. And finally, we ignore the sentiment and emotional tone when it is often critical in news. So our goals were fourfolds, which were to build a framework for timestamp summarization using AI, and to improve the accuracy and contextual relevance using transformers, and to evaluate the output and the quality of the news and the summaries. Next was to ensure the system works on large scale data with processing time. Next, I have Anish to present it.
So good morning all. So our project aims to address the challenges of information overload by building a time-aware summarization system. The key objectives to implement the key techniques to implement these objectives are NLP, used to process, extract and understand the structure of news data. Abstractive summarization, implemented using transformer based models like BERT and T5 to generate human like paraphrased summaries. Timestamp based segmentations, articles are grouped into user defined time slots, daily, weekly or monthly, to maintain chronological order. Named entity recognition, to highlight important entities such as people, places, and organization, enhancing relevance. Configurable pipelines. Summary length, inclusion of sentiment, and metadata can be customized based on user needs. Our methodology is broken down into five key stages. The first one is data collection and pre-processing. We collect data from sources like news sites, Twitter, and archives. Pre-processing involves cleaning, tokenization, sentence segmentations, and named entity recognition to identify key entities and align them with the time. Next, timestamp extraction. Both explicit using regex and implicit using models like BERT-time and T5. Temporal expressions are identified and normalized. Moving on, event detection and classification. Events are detected using models like BERT GPT. Events are classified by type, for examples like political, social, economical, and grouped using cluster method like k-means and LDA. Summarization and ranking. We use extractive models like TextRank, BirdSum, and abstractive models like Pegasus and T5. Summaries are ranked based on frequency, impact, and recency of events. Model training and evaluation. Training is done using datasets like Wikipedia, News 2016, and TimeML. Models are fine tuned for domain relevance and evaluated using Rogue 1, Rogue 2, and Rogue L scores. Moving on, the system is built using modular event driven and serverless architecture for flexibility and scalability. Microservices handle specific tasks like data ingestion, summarization, and storage. Serverless function allow on-demand processing and scaling for high volume loads. Event-driven pipeline triggers summaries based on new data arrivals or time schedules. The backend supports summary export, analytics display, and performance visualization. So this design will ensure the platform is highly adaptable for various domain and use cases. Thank you.
Thank you for your presentation, sir. Do you have any questions?
There's no questions from my side.
Okay, sir. Moving on to the next presenter. I would like to call again Sir Sarthak to present his paper on the title, Brick Manufacturing Using Embedded System. May we have you here with us, sir? Do we have anyone else from the team with us? Since there's no response, we'll be moving forward with the session. I sincerely thank our authors for their excellent presentation and contribution in this session, and all the participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during this 10th version and all the previous 9 versions of the conference. We'll be happy to have you in the 11th version in 2026. All the presenters will be getting their digital certificate through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICT4SD 2025. I also thank the session chair, Dr. Vijay Mali, for chairing this session. I would now like to request Sir to share his thoughts on the presentations that were given in the session. Over to you, sir.
Ashutosh, I just come outside. I think all presentations are done.
Yes, sir.
Yeah, okay. So I congratulate all the presenters and wish you all the best for your research, future research. Many papers I saw that was basically from literature survey. So my best wishes for them for the future implementation, and hope maybe in the next session of this conference they will come with their implementations. Thank you once again. Thank you organizers. Thank you Ashutosh and madam for nicely organizing this session and giving me an opportunity to chair this session. Thank you very much.
Thank you, sir. Here's token of appreciation to the chair on behalf of Team ICT4SD 2025 and Global Research Foundation and partners. Thank you everyone for a valuable presence. Just before we end the session, I request you all to switch on your camera for a quick snapshot of the virtual conference. Thank you everyone.